This example, we have the system of differential equations as dx dt equals 4x minus 3y and dy dt equals 6x minus 7y with initial conditions x at 0 equals 2 and y at 0 equals negative 1. Recall x and y are the function of the t. X and y, we call them as a dependent variable and t as the independent variable. The capital D operator represents the derivative. The capital Dx is the dx dt or the derivative of the x with respect to t, same as the capital Dy as dy by dt or the first derivative of the y with respect to t. To solve this system of equations, we are going to use the systematic elimination method, which means we are going to write it in the systematic way and also eliminate one of the dependent variables, and after that we substitute to get the other one. To rewrite it in the systematic way, replace dx dt with the capital Dx or the operator dx, the dy dt with the capital Dy, and rearrange the numbers, the terms. So the first equation becomes dx minus 4x plus 3y equals 0. And the second equation becomes negative 6x plus dy plus 7y equals 0. And we write as d minus 4 of the x plus 3y equals 0, negative 6x plus the quantity d plus 7 of y equals 0. And next we are going to eliminate one of the dependent variable. So we're going to eliminate the variable x. To eliminate the variable x, we are going to make the coefficient to be the same but opposite inside. So multiply the first equation by positive 6 and multiply the second equation by the operator d minus 4 to get 6 d minus 4 of the x plus 18y equals 0. And the second one becomes negative 6 d minus 4 x plus d minus 4 times d plus 7 y equals 0. And then we add these two equations. The first terms involving x will be gone. Now we get d minus 4 times d plus 7 y plus 18 y equals 0. Expand them all out to get the equation as d squared plus 3d plus minus 28 multiplied by y plus 18y equals 0. Expand them all out and simplify like terms to get d squared y plus 3dy minus 10y equals 0. Recall dy means the derivative of the y with respect to t. D squared y means the second derivative of the y with respect to t, or y double prime. And this is the same as y double prime plus 3y prime minus 10y equals 0, which is the linear second order with the constant coefficient. And this is a homogeneous equation of the variable y. To solve for y, we're going to use the auxiliary equation, which is m squared plus 3m minus 10 equals 0. Factor completely to get m plus 5 multiplied by m minus 2 equals 0. Or we get m equals negative 5 or m equals positive 2. And then put together as a complementary solution or the general solution for this y. Solution y will be c1 e to the negative 5t plus c2 e to the positive 2t as a general solution for the y. And then we're going to use y to find the x. to find the X solution. To get the X solution, refer to the system of differential equations that we started with, which is in the form of dx dt equals 4x minus 3y and dy by dt equals 6x minus 7y. For our convenience, we're going to use the second one. That means we're going to start with phi dy by dt, or negative 5c1 e to the negative 5t plus 2 c2 e to the 2t. And then replace it or substitute into the second equation. From dy by dt equals 6x minus 7y. We solve for x, we're going to get x equals 1 over 6 multiplied by dy by dt plus 7y. And from what we did earlier, dy by dt, which is negative 5 c1 e to the negative 5t plus 2 c2 e to the negative e to positive 2t, and then plus 7 of the y, which is 7 c1 e to the negative 5t plus 7 c2 e to the 2t. Combine like terms. For the exponential e to the power negative 5t, we get 2 c1 e to the negative 5t. And for the exponential e to the power 2t, we get 9 c2 e to the 2t. Multiply all by 1 over 6 to get 1 over 3 c1 e to the negative 5t plus 3 over 2 c2 e to the 2t for the x solution. Now we have x in terms of 1 over 3 c1 e to the negative 5t plus 3 over 2 c2 e to the 2t, and y as c1 e to the negative 5t plus 7c plus c2 e to the 2t. So this general solution as x and y function of the t for this system of differential equations. Next, we're going to use the initial conditions to find C1 and C2 to get the solution to the initial value problem. From x at 0 equals 2, y at 0 equals negative 1. And we have x in terms of t as 1 over 3 c1 e to the negative 5t plus 3 over 2 c2 e to the 2t, and y as c1 e to the negative 5t plus c2 e to the 2t. As t equals 0, we get 2 equals 1 over 3c1 plus 3 over 2c2. And for t equals 0, y equals negative 1. Negative 1 equals c1 plus c2. Now we're going to solve for c1 and c2. Eliminate c1. So multiply the first equation by negative 3 to get negative 6 equals negative c1 minus 9 over 2 c2. And subtract these two equations, add these two equations to become negative 7 equals 1 minus 9 over 2, which is negative 7 over 2 of the c2, or c2 equals the value 2. After we get c2 as 2, then we're going to use c2 to find c1. So then C1 equals -1 minus C2 or -3. Then the solution in the form of x equals C1, which is -3 divided by 3, gonna be -1 e to the -5t. And C2 is 2. It becomes plus 3 times e to the 2t. And y as -3 e to the -5t plus C2 or plus 2 e to the 2t.